Multiply is a cancel problem, so we're going to cancel. 4 and 8 will both cancel by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 7 and 21 will both cancel by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. And then remember, it's just right across on each level then. 1 times 3 is 3. 1 times 2 is 2. How about 3 halves? We have a division problem next, and we threw in some mixed numbers this time. And we know that with multiplication or division, that means we need to convert to improper fractions first. So let's get some of you involved. Let's pair Brock with Aaron. How would you convert 2 and 5/8 to an improper fraction? What would that give me? 21/8. She said 21/8. She's right. 2 times 8 is 16, plus 5 is 21/8. Divided by Shirley and Tristan. What are you thinking about 1 3/7? 10/7, okay. 1 times 7 is 7, plus 3 is 10/7. And in class, what's the difference between a multiply problem and a division problem?
You have to multiply letters.
That's right. On a division problem, we have to flip the second one. Flipperoni. So we're going to have 21/8 times 7/10. And now it's a cancel problem. Now 21 is not going to cancel with 8, nor will it cancel with 10. 7 is not going to cancel with 8 or 10. So in this problem, we're just going to multiply across. 21 times 7 is 147. 8 times 10 is 80. How about 147/80? Now, you guys tell me what you want to do. Here's an add problem, and we've got mixed numbers. So if I'm reading you correctly, most of you are telling me that you prefer to work these as improper fractions and not mixed numbers. Am I right or am I wrong on that?
Yeah, you're right.
Okay, so let's go that direction then. 5 times 4 is 20, plus 3 is 23/4. Plus 3 times 3 is 9, plus 1 is 10/3. Hey, Cody and Christian, is that a common denominator problem or a cancel problem?
Common denominator.
What is the common denominator?
12.
Okay, let's rewrite both in 12ths. Four times 3 gives me 12, so I'd have to take 23 times 3. Somebody got a lead on that?
69.
69, good. 3 times 4 is 12, so I'd have to take 10 times 4.
40.
And are they frozen? Can you guys still hear me? Okay. So now that we're at 69/12 and 40/12, we're going to have an answer in 12s. Or at least my next step is going to be in 12s. 69 and 40 is 109. I do need to see if that'll reduce. You're like, I don't know. Well, let's think through it. Okay? Let's think about the factors of 12. Like 2. 2 won't go into 109 because it's not even. 3 goes into 12. If you checked 109 divided by 3, you would not get a whole number. 4 goes into 12, but you know an even number cannot go into an odd number. 6 is even, so there's no way it could go into an odd number. And 12 is even, so there's no way it can go into an odd number. So guess what? It's simplified. 109 over 12. Okay, so that's section 1. Do you guys feel good about section 1 or not so good? All about fractions. Okay, let's change our color here in section 2. I'll go to red here. Section 2 is about the evaluating expressions, which means we're going to use the order of operations, which we've talked about many, many times now. Parentheses, exponents, multiply, divide, add, subtract. And I kept suggesting to maybe even just use that as a checklist. So, considering this first problem, if we work inside the parentheses, the innermost set of parentheses is that 11 plus 3, which is 14. So I do 3 squared times 14 minus 4. Parentheses aren't done, so I better keep going. So I'd have 3 squared times 14 minus 4 is 10. Now the parentheses are done. Hey class, what's next on this problem?
Exponents.
Which would mean to do what here?
3 times 3, 9.
3 times 3 is going to give you 9, they say, and they are right. So the exponents are done. Now we'll multiply or divide left to right, and 9 times 10 is 90. Okay, so this other problem is just more of the same. So if we work inside the parentheses on the other problem, inside the parentheses here I have addition, multiplication, and an exponent. So I know I have to do the exponent first. So the first thing I'm going to do here is cube 3. 3 times 3 is 9, and 9 times 3 is 27. That's what you meant.
Yeah.
Okay, now inside the parentheses I have addition and multiplication. So I got to multiply before I add. It's not doing anything with the 6, not doing anything with the 2, not doing anything with the plus. I am taking 27 times 8. It's just 56, and carry the 5. 2 times 8 is 16, and 5 is 216. So 8 times 27 is 216. Still got to work inside the parentheses. 2 and 216 is 218, and the parentheses are finally done. There are no exponents on this problem. We'll multiply and divide, and that's all we got left to do. Let's see, 6 times 8 is 48, carry the 4. 6 times 1 is 6, and 4 is 10, carry the 1. 6 times 2 is 12, and 1 is... How about 1,308? Class? Okay, so That is by and large what we talked about in section 2. In section 3 we talked about the same thing, except notice it's entitled algebraic expression, so we introduced the notion of a variable to you. So I'll tell you what, I want you to change the problem that I put there. Instead of y equals 1, the reason I don't like y equals 1 is you could actually work the problem wrong and still get the right answer if I leave that. So why don't you make it y equals 3, and then you guys get out in front of me here a little bit and go to work on that one a little bit. So if you put the 2 in for x and the 3 in for y, you'd have 4 times 2 plus 2 times 3 plus 7. And again, you got to apply the order of operations. There are no parentheses, no exponents. The next thing you got to do is all of your multiplication or division. So 4 times 2 is 8. 2 times 3 is 6 plus 7. And then you add, subtract from left to right. How about 21, class? All right. Let's move on to section 4 then. The big topic out of section 4 was sets of numbers. So before we tackle the problem, maybe we should go down here on my screen here and review what we said about sets of numbers. Okay, and here's what we said. The natural numbers is not on the screen. There we go. The natural numbers are the counting numbers. 1, 2, 3, 4, so on and so forth. No fractions, no decimals, no negatives, no zero. Now, does anyone in the class remember the difference between a natural number and a whole number?
Whole number has 0.
Whole numbers have 0, so the whole numbers have 0, 1, 2, 3, 4, no fractions, no decimals. Notice that all the natural numbers are also whole numbers. Okay, do you remember what we pick up between whole numbers and integers? We pick up negatives, but still no fractions and no decimals. So integers look like this. -3, -2, -1, 0, 1, 2, 3, blah, blah, blah. No fractions, no decimals. Okay, and then the integers are types of rational numbers, but we also had irrational numbers. So this is where we pick up our fractions and decimals. Now, rational number was anything that could be expressed as a ratio. An irrational number was anything that could not be expressed as a ratio. If you remember, we said that mostly the numbers in our class that cannot be expressed as a ratio would be square roots, but not square roots like 49, because that's 7, which we know is rational. So we'd be talking about square roots of something that we don't know, like square root of, say, 30. I don't know what that is. It's going to end up being irrational. or even something like the square root of 6. So pretty much every other thing in our class, besides irrationals, is going to be rational. The only exception to that was a number over 0, which we said is undefined.
Non-repeating decimal.
An irrational number is a repeating decimal, is a non-repeating decimal that never ends. So it goes on forever. So you're right, non-repeating decimal, but also non-terminating, it never ends. And then when I put those two sets together, I end up with the set of real numbers. Okay, so going back to our problem then. We were given this set of numbers, and we were asked first about, out of that set of numbers, which numbers are natural numbers. So let's ask that question to Shirley and Aaron.
That's not a 2, that's 0.2.
That's a 1.2 right there.
I have to see that since you enlarged it.
Yep.
Are you asking for like all of them?
Out of this set of numbers I have here, which of those are natural numbers?
3.
3 is the only one, right?
Yeah.
Good. You're right. So the natural number in that set is 3. Okay. Let's go to Brock and Tristan. Out of this set, which of those numbers are whole numbers?
0 and 3.
0 and 3 is correct. 0 and 3. Okay, let's go to Cody and Christian. Out of that set of numbers right there, which ones are integers? And I'll tell you what, let's do this one different. I'll give you the number, you tell me yes or no. Okay? Negative 5.3, is that an integer?
No.
Why not?
Because it's decimal.
That's right. Negative 5.
Yep.
Okay, so we'll put a check mark there. Negative the square root of 3.
Nope.
Nope, that's going to be some kind of icky decimal. Oops, I should have underlined that one. I put a check mark, so that's a new. David, new. How about negative 1?
Yep.
Okay. Negative 1/9.
Nope.
Why?
Because it's a fraction.
That's right. 0.
Yes. No, it's irrational, isn't it?
Nope. Irrational number is going to be one that goes on and on and on and never terminates and never repeats.
Gotcha.
Okay. How about 1.2?
Nope.
Why?
Because it's a decimal.
That's right. How about 3?
Yes.
Yes. So what have we got? Negative 5, negative 1, 0, and 3. Okay, now we can either find the rationals next or we can find the irrationals. Sometimes I like to find the irrationals before I find the rationals. And I see a square root in there. Negative the square root of 3. And I don't know what square root of 3 is. So it's going to be irrational. And if I'm not irrational, then most likely I'm rational. So your rationals would be all of them that now have check marks which would be everything except negative square root of 3. So sections 5 and 6 were about adding and subtracting and multiplying and dividing. And now that we've done section 8, we don't have to change our subtraction to addition. So 13 minus 28, you would just say the signs are different. So therefore, we're going to subtract. 28 minus 13 is 15. 28 is bigger than 13, so we get negative 15. If we get a double negative, like we have over here, then we just know that we got to distribute this negative first. So if I do that, I would have negative 6 plus 2. Hey class, what's negative 6 plus 2?
4. Negative 4.
Which is it, 4 or negative 4?
Negative 4.
Why is it negative?
Because you carry the box number has the negative.
That's right, 6 is bigger than 2. Well, I did a couple more of those on the other side of this page. 4 plus negative 9, the signs are different. So I subtract. 9 minus 4 is 5. 9 is bigger than 4, so I get minus 5. Whoop-de-doo. Hey, main campus, what about negative 12 plus negative 6?
What?
How about negative 12 plus negative 6?
Negative what?
No,
No, that's 18.
It's 18? You're
Negative 18.
negative 18. Which is it? Negative 18 or 18?
No, it's negative.
It's negative 18, that's right. Because the signs are the same, you got to add to the number, keep the sign. Good. And you know I'm going to give you some fractions with positives and negatives. So you have to always ask yourself, is that a common denominator problem or is that a cancel problem? Class, 3/5 plus negative 2/7. Which is it?
Common denominator.
What's common denominator between 5 and 7?
35.
All right, let's go for 35. Now remember that negative on the second one we can put in the numerator. Okay, Kristen and Tristan, what do you think this first numerator should have?
9.
You go with 9, okay.
No, 21, I think.
21, okay. 5 into 35 goes 7 times. And 7 times 3 is 21. Okay. What about the second numerator?
Negative 10 right there.
Be negative 10. 7 into 35 goes 10, or 5 times, and 5 times 2 is 10. What's the answer, class?
1135.
That's right. Signs are different, so 21 minus 10 is 11. 21 is bigger than 10, so I get positive 11 35ths. That seem easy or hard to you at this point? Did it seem easy or hard when you started the class? Easy then, easy now? Okay, section 6 was multiplying and dividing with positives and negatives. So obviously we've said many times by now that when the signs are the same I should get a positive. So negative 7 times negative 4 is positive 28. And when the signs are different, I should get a negative. Now, I'm going to rewrite this problem because I'm out of room up here, but I have to again consider when I'm multiplying, is that a cancel problem or a common denominator problem? It's a cancel problem, and we know also that our answer is going to be negative because when the signs are different, I get a negative.
You're right.
Well, 3 is not going to cancel with 8. 3 is not going to cancel with 5. 2 and 8 will both cancel by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So how about 3 times 1 is now 3, and 4 times 5 is 20? How about negative 3/20ths? Well, the only thing that leaves us is a problem like this, and we did where we have to translate. Now the directions here say translate and simplify. On your test, I'm just going to ask you to translate. I'm not going to ask you to simplify.
Do we get bonus if we simplify?
No, but it doesn't hurt to ask. So I don't blame you for asking. And we know that where it says a number, that's where we want to start. That's where x is going, and we'll work our way out from there. So if we put 5 more than a number, that would be 5 plus x. We want the product of 9 and that, and product means to multiply. And it's multiplied by this whole thing, so we want parentheses. And we'd want a 9 out in front of that thing. Now, that's the kind of stuff that's coming on your test. This review assignment at the bottom of your paper is, for all intents and purposes, a practice test. So look, I gave you only 2 even problems on this whole assignment. So all the rest of them are in the back. When you can do this by yourself and check them in the back and they're right, that's when you're ready for the test. Don't consider yourself ready for the test until you've done that. Okay, but when you can do that, you're good to go